hello. Hi, grade 10s. It's been a while. I haven't been on a Monday show since last term even. Hope you guys are doing good. I'm Looney and it's time for grade 10 maths and that is Natasha.
Hello,
How are
Looney.
you?
Good, how are you?
I'm good, thanks. What are we doing for the grade 10s?
Well, grade 10 today we're looking at graphs and functions. We're looking at linear graphs and we're looking at hyperbole. And I hope that you're all in the mood to learn because I was just saying to Looney, it still feels like it's pretty much holiday.
Yes, we've been on holiday for the longest time. Long
Way too long.
weekends have been like successive. But mindset is I hope you guys are ready to learn more and learn extra with us. Don't forget to hit us up on Facebook and on Twitter at Learn Extra. And remember, you can download all the show notes, the videos, and the schedules on learn.mindset.co.za. But I will post everything on our Facebook page, so don't sweat, guys. If you need all the information, it's on our Facebook page. Remember, we have notes to view and to download. So if you don't have a smartphone, you can still view the notes, and then if you want to download them, you click the download link. Remember, we also have the Taste Yourself competition still running. If you want to win yourself an awesome Casio calculator, all you need to do is complete the questions on the entry form and then you press the submit button, guys. Remember to fill in all your details and then click submit. And remember, guys, entries do close on Friday at 12 in the afternoon. So you have the whole week to fill in the questions, to think about your answers. And then Friday 12, we close the competition so that next week during the live shows we can announce the winners. So remember, guys, test yourself. You complete all the questions and then you submit. Entries close on Friday. So all that said, Natasha.
All right, guys. Well, I hope that your brains aren't on holiday mode. And remember that a holiday is really just a study break in disguise. So I hope that you've all made good use of your time and that you have still been going over your work and it's all not completely brand new to you. So as I said, today we're looking at hyperbole and we're looking at linear functions. Specifically, we're going to look at sketching linear and hyperbolic functions. And we're also going to look at the effect of the variables a and q on both straight lines and hyperbole. All right, your challenge question for today. You are given the graphs, the straight line y is equal to x and the hyperbola y is equal to 8 over x. That's shown in your diagram. And then you're asked a whole lot of questions based on that diagram. So make sure that you can see your diagram clearly. Ask us if anything's not clear. You're asked to find the coordinates of A and B. You then need to find the length of CD, calculate the length of AB as part C, and then finally part D, find the length of EF. If you are given that point G is the point -2 and 0. So hopefully you all have enough tricks up your sleeve to be able to answer this one already, but if not, by the end of the lesson you will be able to answer this. Okay, so let's get straight into it with a quick summary. All right, I just want to remind you guys about linear graphs, the defining equation. Y is equal to mx plus c. Now, some of you will see it in your textbooks, or maybe sometimes your teachers prefer to use y is equal to ax plus q. Guys, those are exactly the same thing. So don't let the different variables here confuse you. It's exactly the same. Both are perfectly acceptable. All right, a few things for you to remember. If you're using A's for a greater than 0, or if you're using m stands for gradient, for m greater than 0, so we're just looking at the positive values. Remember, the higher the value of a or your gradient, the steeper your line will be. Now, if you change the value of q, that q being your y-intercept, this is actually going to imply that your graph's going to slide along the vertical axis. So it's going to be a vertical movement of the original graph. So depending, so if we have some straight line, all right, and that's our line there. And now q, remember, being your y-intercept, if you change the value of q, so if q is positive, we increase the value of q, you're going to have a vertical shift upward. And then if q is less than 0 or negative, you're going to have a vertical shift downward. So that's what q is going to do to your graph. M is going to affect the gradient, so it's going to affect the sloping of your graph. How steep is your graph? All right. Remember, with your domain and range, your domain for straight lines or linear functions is x is an element of real numbers. And then your range, which is your set of y values, is y is an element of real numbers. And that's for any straight line that's not on a restricted domain. All right? Okay, then moving along to hyperbole, remember the defining equation is y is equal to a over x plus q. Now, when your value of a is positive, so when it's greater than naught, the graph will lie in the first and third quadrants. And guys, that should make sense to you, because if you think about values, in your first quadrant, we're looking at all positive x values and all positive y values. So the product of those two is going to be positive. So you'll have a graph that lies in the first quadrant, and then for a greater than naught, again, positive values of a. If we look at the third quadrant, we have negative x values and negative y values. If you multiply those together, again, you get a positive answer. So therefore, for a greater than naught, your graph will lie in the first and the third quadrant. Similarly, if you have a negative value for a, so a is going to determine your shape, the graph will lie in the second and fourth quadrant. Again, because if you take the product of your x and y values in the second and in the fourth quadrant, your product will be negative. Okay. Y is equal to q, that is the horizontal asymptote. Now, asymptote, remember, your graph is undefined or discontinuous at an asymptote. So no matter what values, if you look at the asymptote, your graph will be defined for no value along that line. So in other words, it will approach the line but never be equal to that y value or that x value. All right, so y is equal to q is the horizontal asymptote. X is equal to naught. X is equal to naught, another word for that, the y-axis. X is equal to naught is your vertical asymptote. Remember, guys, we are restricting this to this type of function. So we're looking at in grade 10, y is equal to a over x plus q. So in grade 10, your vertical asymptote is x is equal to naught. All right? Now remember, you also get your axes of symmetry, which divide your graph symmetrically. The axis of symmetry, the lines are y is equal to x plus q. All right, so in the positive direction, y is equal to x plus q. And in the negative direction, so if we had graphs in the second and fourth quadrant, our axis of symmetry would be minus x plus q. Okay, and again, we're looking at graphs in that standard form that you learn in grade 10. Now, what happens if you change the value of a? Well, that's either going to stretch your graph vertically, or it's going to shrink it vertically. Okay, so a is going to affect the length of your graph. Okay. All right, and just a reminder about your domain and range. So again, we're looking specifically at y is equal to a over x plus q. All right, for your range, you're going to have y is an element of real numbers, y is not equal to q. So this is your range. And then for your domain, you're going to have x is an element of real numbers and x is not equal to naught. All right. Okay, so those are the basic things that you need to remember about hyperbole, and that's what we're going to use through the remainder of the lesson as we look at hyperbole and as we look at straight lines. You need to have all these basics sorted out so that when we do the harder, more complicated questions, you understand and you're with us. Luni, I think we're going to go straight into breaks maybe so that we can get into the questions, which are quite long when we're dealing with functions.
All right, mindsetters, let's take a very quick break. Please stay tuned, because after the break I want to tell you guys about a study group you can join. So don't go anywhere. We'll see you straight after this. Welcome back, mindsetters. From that group, before the break I told you guys about a study group. So if you want to improve your math skills and you want to get better at maths, you can join our Mo Maths group. All you need to do is go to momaths.org, that is momaths.org, and then you join the South African group. And then for grade 10s, what you need to do is that you need to register and fill in this following code, which is 2FB5. That is your invite code that you need to fill in in the MoMats group. Okay, so you register and then you fill in that code 2FB5. And remember, guys, I will post all this information on our Facebook page. This is the calculator that you can win. So remember, test yourself. Ends Friday at 12 in the afternoon, so you can enter as many times, and then Friday it's done, it's over. Winners will be announced next week. So Natasha.
All right, okay guys, so before the break we were doing a bit of a summary on linear graphs and hyperbole, and now we're going to continue with our questions in the Improve Your Skills section. We're firstly going to look at question 1, which is asking us to draw a straight line. Here it's slightly different though, because they've given us a restricted domain. Okay, so they say sketch the graph f of x is equal to 2x plus 1 with domain minus 2, 2. Now guys, remember when you're sketching graphs, there are very lots of different ways you can do it. Well, a few different ways. The one way is you can plot points on a table, or you can use the gradient intercept method, but the one that we prefer, that's used more often to sketch straight lines, is the dual intercept method. So that's the method I'm going to use to draw this graph, but just bearing in mind that our domain is restricted from minus 2 to 2, because remember your normal domain on on straight lines is x is an element of real numbers. That's the normal domain, but now they've restricted the domain. All right, now what that means is that your graph is going to start at minus 2 and it's going to end at x is positive 2. So that's going to affect the end points will be affected on your straight line. So your end points are affected by the restricted domain. And I'm going to show you how they're going to be affected in a second. Okay, on my number line system, I'm going to put a few points on so that when we sketch this we can easily plot the points. So let's just say that's 1, 2, 3, 4, and then on the negative side we've got minus 1, minus 2, minus 3, minus 4. Now you'll notice I've gone way beyond minus 2, but you'll see that when I draw the graph we're not interested in anything that happens to the left there, and neither are we interested in anything that happens to the right, because they've given us a specific point that or specific domain within which we need to stick. All right, and then we've got y is 1, 2, 3, 4, and then the same thing going down, minus 1, minus 3, and minus 4. All right, the first thing we're going to do, guys, is let's look at what happens to this graph. F of x is equal to 2x plus 1. What happens at the end point of minus 2 and 2? What's going to be the output value? So we're going to put in minus 2, see what we get as an output value, and then we're going to put in 2 and see what we get as an output value. So I'm going to say on the side here, f of minus 2. So I want to get my end point sorted out. F of minus 2 is going to be 2 times minus 2 plus 1. So that's going to give me minus 4 plus 1, which is minus 3. So in other words, the x value at minus 2 gives me a y, an output value of minus 3. That's my function value on this graph. Now, remember you dealt with interval notation. The square bracket, that means including the end point. And then the round bracket means excluding the end point. So if I were to represent this minus 2, minus 3, it is an endpoint that's included when I represent it on the graph. Okay, so that coordinate is an included, in other words, closed dot coordinate. All right, then let's look at what happens at an x value of 2. So I put 2 into my function and I get 2 times 2 plus 1, and that's going to give me an output of 5. All right, so my other endpoint coordinate is x is 2 and y is 5. However, if you look at the domain, you will see that that point 2 has been excluded. So therefore, this endpoint will have an open dot on your straight line to show that that point has been excluded from the domain. All right. Now, how would we normally, so we're going to keep this in mind, we're going to come back to that. We're going to use the dual intercept method to sketch the graph as we normally would do. Okay? And then obviously take into account or factor in the fact that we have a restricted domain. Alright, so we've got f of x is equal to 2x plus 1. Alright, so the first thing we do, find the x-intercept. To find the x-intercept, you let y equals 0 and you solve for x. So therefore I'm going to get 2x plus 1 is equal to 0. Therefore 2x is equal to minus 1 and x is equal to minus a half. Alright, so your x-intercept is minus a half. So your coordinate there, minus a half and 0. Alright, then we find the y-intercept, and we find the y-intercept by saying let x equal 0. So if we let x equal to 0, we're going to get f of 0 is going to give me 2 times 0 plus 1, and that's going to give me a value of 1. So therefore my y-intercept is 1. Alright, so we would normally plot those points on the coordinate system and then sketch your graph, join the two dots. So we've got an x-intercept of minus a half, alright, which is there, and a y-intercept of 1. Okay, we will then take our line straight through those points, right? So we would do, alright, I don't want a graph that's got dashes in it, so we're going to just get rid of that one and use a full solid line. Alright, so that would be your line. But now guys, remember you would normally then go and put arrows in at the end of these graphs to show that it goes on forever. However, we've got these two things happening. We've got a restricted domain. So this graph only exists for us, for what we've drawn it for, between the points minus 2 and 2. So the graph is not going to go beyond those 2 points. Alright, I'm going to stretch this out a little bit more so that we get, there we go. Alright, so that's what you have. So we've got at minus 2, the y value is supposed to be minus 3. Alright, and I'm just going to stretch my graph out so that it makes more sense in terms of the scale. So at x is equal to minus 2, we've got a y value of minus 3. That is an included point. So therefore, at the end of this graph, to show an included point, we would put a dot. So it starts from x is equal to minus 2. It goes up until the point x is equal to 2 and y is equal to 5. And that end point is excluded. So you would end your graph off with an open circle. Alright, so with a restricted domain, you've got to take into account what the end points of your graph is doing. Okay, you use those x values to work out your function values, and then you restrict your graph by either using closed dots to show an included point or an open circle to show an excluded point. Alright, hopefully you're all with me and you have been following and you understand how to deal with restricted domains. It's really drawing a straight line as you would normally do, except for bearing in mind that the restricted domain is going to cut the graph out. So you're literally looking at a segment of the graph. You're not looking at the entire straight line. All right. Okay, so we're going to move on to hyperbole, and this is now question 2. We are asked to draw the graph of g of x is equal to 4 over x. And then we're going to use that graph and explain how the graph h of x is equal to 4 over x plus 2 compares to the original graph. We're then asked to draw h of x, which is this new graph 4 over x plus 2, on the same set of axes as g of x, and show all our asymptotes and the points of intersection with the axes. Alright, now the graph of g of x is equal to 4. G of x is equal to 4 over x. First thing we do, guys, we look at the value of a. We know that a is greater than 0, right? So that tells me we're going to have, just a rough sketch, if a is greater than 0, your hyperbola is going to fall in the first quadrant and the third quadrant, because that's the product where your product of your x and y values are positive. So we're going to have graphs within the first quadrant and the third quadrant. All right? We know that everywhere, because remember, you can cross multiply this. So if you have y is equal to 4 over x, we can cross multiply and rewrite the equation of the hyperbola as xy is equal to 4. So what that means is the product of the x and the y values will give us 4 anywhere along that curve. All right? Also, we know that x is equal to 0 is our vertical asymptote. Okay? And we know that y is equal to 0 is our horizontal asymptote. So in other words, the axes are asymptotes to this graph 4 over x. All right, so that means the graph cannot touch those lines. Okay, we know that it's a positive graph, so we're going to have a graph in the first and in the third quadrant. And as you can see, these graphs go away from, they approach your axes, but they don't actually ever touch the axis. So this is y is equal to 4 over x, or g of x is equal to 4 over x. Okay, so that's your basic standard graph. All right, that all of you have seen before. They then say, explain how the graph h of x is equal to 4 over x plus 2 compares to the original graph. Now guys, remember we discussed this in the beginning. So what we've done here is we've changed the value of q, and we've discussed what happens when you change the value of q. Your value of q is going to imply a vertical sliding, a vertical movement of your original function. All right. So in this case, because q is positive, it's positive 2, therefore our graph is going to move 2 units up. So it's a vertical movement of the original hyperbola, and it's going to move 2 units up. So that's how they're saying, explain how the graph compares to the original graph, while it's going to move vertically upwards by 2 units. That's the graph of h of x. Okay, so that's what we understand is going to happen to the graph. All right. They then say, draw h of x on the same set of axes as g of x, showing all asymptotes and points of intersection. So h of x being that. All right, so we've got h of x is equal to 4 over x plus 2. We analyze the graph once more. We know it's basically going to be the same graph shifted up 2 units. But if we were just given this question, asked to draw this graph, we would analyze it from scratch, right? We'd look at a and we'd say, well, a is greater than 0. So we know that that means it's going to fall in the first and the third quadrants. All right. We then look for the x-intercept or the y-intercept. Let's see if we can find any. All right, remember we are dealing with a hyperbola here. So if I were to look for, say, we're going to look for the y-intercept. Okay, and all of you should realize this already here. If we were looking for a y-intercept and we said x is equal to 0, guys, what's going to happen? If I substitute 0 in place of x, I'm going to get an undefined value because I'm getting 4 over 0. So this whole thing is undefined. So therefore, these hyperbole, remember, they're never going to have y-intercepts. Okay, because every time you substitute an x value in there of 0, you're going to get an undefined equation. So therefore, we say x is equal to 0 is a vertical asymptote. All right. We then, if we try to find an x-intercept and we let y equal to 0, again, we're going to end up with an asymptote. You're going to get a graph that's discontinuous when y is equal to 0. Because also, guys, remember, we've said at the outset, when you've got a hyperbola of the form y is equal to a over x plus q, the value y is equal to q is your horizontal asymptote. So therefore, my other asymptote, my horizontal asymptote, is y is equal to 2. Okay, so we need to put that onto the graph. All right? So we're going to have, okay, let's just get a nice color so that we can see it clearly. Let's use the green. So we've got y is equal to 2. That is the horizontal asymptote for the graph y is equal to 4 over x plus 2. So we've got a horizontal asymptote of y is equal to 2. All right? So therefore, if I tried to draw this graph, what's going to happen? Remember, we said already the graph's going to move 2 units up. So you're literally going to see a translation of the graph. It's going to slide up by 2 units. So all I'm going to do to recreate this graph is clone the original picture and then move it up by 2 units. All right. So we're going to get, let's have a look. All right, so we're going to have, this is my original graph, right, as you can see, and that's going to move upwards by 2 units. So that's what your graph's going to look like. So it's almost, as you can see, it's approaching the line y is equal to 2 like it did the x-axis. So that's your new asymptote. Okay, and then the same with this line, with this graph, sorry. It's also going to move upwards by 2 units. Okay, and again, not touch that graph. All right, so that's going to be the vertical movement of your graph. Y is equal to 4 over x plus 2, and it's simply all just slid up by 2 units. Okay, showing all asymptotes. So we've shown y is equal to 2 is the one asymptote, x is equal to 0 is the other asymptote, and we've shown how the graph moves up. It's a vertical shift of the original graph. All right, I think this might be a good time for you guys to take a break and hand it over to Luni.
All right. Mindsetters, I see a lot of you are asking about the Mo Maths group or for the other grades. You want invite codes for the other grades as well. So what I've done is that on the post about the Mo Maths group, I've commented as well for grade 10, 11, and 12. I was going to post it for their shows, but I see grade 11s and grade 12s are also asking for the invite group, for the invite codes now. So I've done that on the Facebook page. So if you go check out right under the post, check out the comments, and then you'll see the invite codes for all the other groups as well. Remember, for the grade 10s, you need to go to momats.org, and then you join the South African group, you register, and then you use the invite code 2FB5 for grade 10s. But as I said, I posted the codes for the other grades as well. Don't go away, guys. We are going to take a very quick break. We'll see you straight after this. What's up, guys? Welcome back. You are still tuned into Maths. I hope you guys are enjoying the lesson. I won't waste any more of your time. I'll take it straight back to Natasha.
All right, guys, I want to do a quick recap of the graph we did just before the break in case there was any confusion. Let's clear it up. We had the graph y is equal to 4 over x, and we then had to draw the graph 4 over x plus 2 on the same axis. What I want to remind you guys is that that is a vertical movement upwards of 2 units. But remember, if you've got any function y is equal to a over x plus q, the steps to sketch this: you first look at the value of a. If a is greater than 0, that will imply that your graph is going to be in the first and third quadrant. Okay, so you look at the value of a, and that tells you where the graph's going to go. If a is negative, that means your graph is going to go into the second and fourth quadrant. All right? We know that in a hyperbola of that form, y is equal to a over x plus q, there is no y-intercept. In other words, x is equal to 0 is the vertical asymptote. All right? The x-intercept, we let y equal to 0. Okay, so for example, if we go back up to our graph, and I think I might have skipped over that part when we did this, but if we let y equal to 0 here, we're going to get an x-intercept. 4 over x is equal to minus 2. So we'll get x is equal to minus 2. All right, so that would be our x-intercept on the left-hand side of the graph, and you can see it's cutting the x-axis at that point, minus 2. So you will let y equal to 0 to get your x-intercept, and then your horizontal asymptote is y is equal to q. All right, so we get our asymptotes, we get our intercepts, remembering that there is no y-intercept, and we look at the shape to help us sketch the graph of our hyperbole. All right. Okay, now guys, I think it's time for us to get straight into the challenge question. It is quite a long one, so I want to start it now, and hopefully Luni will tell me that you guys all got it right, because that's what we want to hear. But more importantly, that you attempted it. All right. So this one, we were given the graph y is equal to x, which is a straight line, and y is equal to 8 over x. They are shown. So if you analyze this, we're basically given the axis of symmetry and the hyperbola y is equal to 8 over x. All right. We are asked to calculate the coordinates of A and B. Now, guys, if you look at the points A and B, which have the round white dots in your diagram, okay, you will notice that those are points of intersection. And how do we find points of intersection? We have to solve simultaneously. Okay, you'll remember that from the previous work that you've done. If I want to find the coordinates of point A and of point B, I need to solve the two equations simultaneously. So this is part A. All right. So we've got the graph y is equal to x, and then our hyperbola was y is equal to 8 over x. All right. Now we're trying to find the coordinates of A and B, which is where your axis of symmetry goes straight through the turning point of the hyperbola. How do we do it? We solve simultaneously, because remember, at the points of intersections, everything about the two graphs is exactly the same. So it has exactly the same x and exactly the same y coordinates at the points A and B. So therefore, I can say, if I call this equation 1 and I call that equation 2, substitute equation 1 into equation 2, and then we're going to solve simultaneously. So therefore, I'm going to get, in place of y here, I replace it with x. So I get x is equal to 8 over x. Okay, and then we can cross multiply. So we get x squared is equal to 8 times 1, which is 8. All right, so x squared is equal to 8. Therefore, x is going to be equal to plus or minus the square root of 8. All right, so therefore the x value at that point is plus root 8 or minus root 8. Which point are we talking about? Well, let's look at A and B. Obviously, because that's in the first quadrant, we must use the positive value for x there. So that's going to be positive root 8. All right, and then on the other side at point B, we're going to have negative root 8. Your y coordinates at point A, sorry, because y is equal to x, we would substitute, if we go back to our simultaneous equation, substitute that back into equation 1. And y is equal to x, so therefore we'll get the one point of intersection is root 8, because y is equal to x. That's the point A. And then B is the point minus root 8 minus root 8. Okay, so on our graph, if we show that, A is the point root 8 and root 8, and then B is the point minus root 8 minus root 8. Okay, so those are the 2 points. How did we find it? Very easily. We just did solving simultaneously, and we found the points A and B. All right. They then say find the length of CD. Now guys, if you have a look at the length of CD, you will notice that BC is a perpendicular to your x-axis going from the point B. So what that means is that the x value everywhere along that line is going to be exactly the same. So therefore the x coordinate at point C on the x-axis, that's going to be minus root 8 naught. Okay, and then similarly AD is perpendicular to the x-axis. They're going to have points A and D are going to have the same x value. Therefore D is going to be the point root 8 and naught. Okay, now if I want the distance from C to D, so that little section there, we want that distance there. All we're simply going to do, because remember we're looking at a perpendicular distance, therefore all we're going to do to get that value, or we're looking at perpendicular points from the points A and B, once we've got the two x values, we're going to simply look at the horizontal distance between the 2 points. So therefore for part B, your distance CD is going to be equal to the difference between the 2 points. So CD is going to be root 8 minus root 8. Okay, so that's just the horizontal distance between the 2 points. I get root 8 plus root 8, because I times the minus into the bracket, and that's going to give me 2 root 8. If you wanted to, or if you were asked to, we could simplify that further, but for our purposes for now, we're going to leave it in that form. All right, so we've got the length of CD as 2 root 8. Okay. Part C, we have to calculate the length of AB. So guys, again, analyze your diagram. If we're looking for AB, and you'll see that AB, look at what that's doing. All right, we've got this distance from A to B. We can see that there's a little triangle in each quadrant that includes the lengths AO and OB. So we can actually split that segment up into 2 pieces. So if I look here, there's one little triangle there, and then in the third quadrant we have another triangle. So I've got a 90 degree, I've got a triangle, I've got some lengths. That should get me thinking about Pythagoras, right? So we know that the length from O to D is root 8 units, right? We know that the length from A to D is root 8 units. How do we know that? Remember, it's the same perpendicular line, so we simply subtract the 2 y values to get your vertical distance. So we know that AD is root 8. We know that OD is root 8. All right? These triangles are exactly the same. We would call them congruent. So we know that's root 8 and that's root 8. So therefore, all I would need to do is find the distance of one of these, and it's going to be exactly the same. So if I work out AO, OB is going to be exactly the same. All right? So therefore, if I use, this is part C, in triangle AOD, all right, we can say that AO squared is equal to AD squared plus OD squared. So this is from Pythagoras. OA squared is equal to AD squared plus OD squared. And we know that the lengths of AD and OD, and this is by Pythagoras, we know that those lengths are root 8, so that's going to be root 8 squared plus root 8 squared. The square root of 8 squared, remember, a square and a root, you're basically multiplying the same thing by itself, so they just cancel out. If you square a root, it will just cancel out to give you the number inside. Root 8 times root 8 is the square root of 64, which is just 8. Similarly, on that side, we get OD squared is going to give me 8. So I get OA squared is 16. Therefore, OA will be the square root of 16, which is 4. Remember, we're looking for a length, so we're going to ignore the negative part of OA. So therefore, OA is 4 units. And we said those triangles are exactly the same. They've got the same distances. So therefore, OB must also be 4 units. So if I add it all together, we know that AB is going to be made up of the two segments OA plus OB. So it's going to be 4 plus 4, which is simply 8 units. All right. Okay, hopefully all of you guys followed that, and remember, if you have any questions, we'll see if we can fit them in with Looney. All right. Remember that if we're looking for the length of AB, all we did was I simply broke it up into two little triangles and found two separate segments, OB and OA, found the distances of those, found the lengths of those pieces, and then added it all together using Pythagoras. We found each of the distances. All right, part D of our challenge question, the last part, it says, find the length of EF if G is the point -2 and 0. So they tell you G is -2 and 0. We've got quite a lot going on in this diagram, so I'm going to take it all off, and hopefully you guys already have all of this down on your diagram, so you don't need all of that other writing. Okay, so they tell us that G is the point -2 and 0. Now remember, G and F and E all lie along the same vertical line. All right, they're all perpendicular to the x-axis. So therefore, if the x value there at point G is -2, then the x value here at point F is -2. We don't know what the y value is, but we know that the x value there at that point is going to be -2. Also, we know that the point E here, it's also going to be an x value of -2, and then again, we don't know what the y value is. Now, if you are looking for this distance, EF, so we're looking for that distance there, that's a vertical distance. So all you've got to do to find the vertical distance is you say top graph minus bottom graph. So the y value at that point minus the y value at that point, because we're talking about points on the same vertical line perpendicular to the x-axis, those values, if I want to find the distance between F and E, it's simply going to be the y value at point F minus the y value at point E, and that will give me my distance. But the first thing we need to do, guys, we know the x value is -2 at F. What is the y value? We need to work it out. We know that the x value at E is -2. What is the y value? Again, we need to work it out. Now, if you look at the point F, that lies on your straight line, y is equal to x. So therefore, intuitively, you don't have to do any working, because if y is equal to x everywhere along this line, if the x value is -2 at point F, then the y value must also be -2. So F is the point -2, -2. Okay, that's the coordinates of F. And then we want the y coordinates at point E. All we're going to do is take the x value of -2, substitute it into y is equal to 8 over x to work out what the y value would be. So I say y is equal to 8 divided by x is -2. So my function value is going to be -4. So therefore, the coordinates at E, the coordinates are going to be -2, -4. All right. So to find the distance FE, we're going to say the top y value, which is -2, minus the bottom y value, which is -4, and that's going to give me that vertical distance. So I get -2 plus 4, which gives me 2 units. So therefore, the distance EF or FE is going to just be 2 units. All right, that's quite a lot to take in. I do know that it is. I hope that you've all been following, but I'm just going to check with Looney over there to see if everyone's been following or if we have any questions.
We do have a question, but not about the challenge question. It just says, it's from Kingsley Wright, and he says, I don't understand the second question.
The second question, I'm assuming it is this one?
Yes.
All right, but what part of it? Because we had a couple of different parts there. what did you say, Kingsley?
Yes.
Kingsley, all you need to remember is what I showed you here was we took the graph of 4 over x and we simply moved it up 2 units. So it was a vertical movement upwards of 2 units. Okay, and what we had to remember is because we're dealing with the graph 4 over x plus 2, there's going to be a horizontal asymptote, okay, and the asymptote is at the point y is equal to q. So in this case, your asymptote was y is equal to 2, and that you see that I've drawn in green, and you literally just move your pink original graph, you move it up by 2 units, so your graph is simply sliding along, so it's just vertically moving upward by 2 units. To draw this graph, what we also needed to do was find the x-intercept, and we found that by letting y equal to 0, and once we've got the x-intercept, we've got the shape, we've got the asymptote, we simply sketched the whole thing. All right.
That's the only question we have.
All right, so hopefully Kingsley is understanding now, okay?
Yes.
All right, so Luni, are we going to have time to do our test yourself questions?
Yes, we are.
Okay, let's get straight into those. All right, guys, so here, remember, this is where you're supposed to be testing yourself. Hopefully, all of you guys have tried this. It is, I think, quite nice because it tests little things that you might have just, you think is so obvious and you just know the answer. And that's where sometimes you need to give a little bit more thought because it can be a little bit tricky. Okay? So this is question 1 in Test Yourself. It says, state whether the following statement is true or false, and if false, provide a reason for your answer. So they say the given or chosen y value is called the independent variable. Now guys, think about this. You know this. We're dealing here with function values. So if we have f of x, for example, let's take any function, is equal to 2x plus 1. All right? Remember, if we go back to sketching this straight line from scratch, what you would normally do is you would choose the x values and your y values would depend on what those x values were. So for example, if we had 1, 2, 3 for x, those are the values we chose, hence x was called the independent variable. We chose those values, and then the values for y would depend on whatever values we chose for x. So the y would change. It was dependent on what we chose for x. So therefore this answer here is false. The given or chosen, we didn't choose the y values, we chose the x values. So therefore that is called the independent variable. The y is called the dependent variable. Okay, so y is your dependent variable. The x one, the ones that you choose, those are called your independent variables. Right, question 2. Again, state whether the following is true or false. And once again, we need to say why if your answer is false. The y asymptote of f of x is equal to 3x plus 4 is y is equal to 4. Now, firstly, you've got to ask yourself, f of x is equal to 3x plus 4. What type of graph is that? Okay, and there is where your answer lies, because if you look at f of x is equal to 3x plus 4, that is simply a straight line. And remember, your straight lines don't have any asymptotes. It's only, up to this stage, with what you've learned, it's only your hyperbole that have asymptotes. So therefore, this one is false. Y is equal to 4 is actually the y-intercept of the graph. Okay, it's the y-intercept, and your straight lines do not have asymptotes. Okay, no asymptotes for straight lines. All right, so we only managed to get through 2 of those. Hopefully you got the rest of them. Thank you for joining me. I'll see you next week.
All right. Thank you, Natasha, for the lesson. Mindsetters, thank you for tuning in. Until next time, we'll see you then.